In this video, we will solve a problem on utility maximization and how to prove that the demand functions are homogeneous of degree 0 in prices and income. The question is, consider the utility function u is equal to x to the power alpha times y to the power beta. Alpha is greater than 0, beta is greater than 0, which is to be maximized subject to the budget constraint, that is m is equal to px times x plus py times y, where m denotes the nominal income of the consumer and price of x is being denoted by px and price of good y is being denoted by py. Okay, we have to derive the demand functions for good x and y, and we have to prove that these demand functions are homogeneous of degree 0 in prices and income. Okay, so what we are being given? We are being given the utility function of a consumer. That is, this is in fact called the direct utility function. That is, utility is a function of two goods, that is x comma y, which is being given us as x to the power alpha times y to the power beta. Okay, this is in fact the Cobb-Douglas utility function. Okay, now what the consumer wants to do, the utility function of the consumer is being given by this. The consumer's endeavor is to maximize his utility. Okay, so he wants to maximize his utility subject to the constraint that he is facing. The constraint is that is the price of x times units of x he will purchase plus price of y times units of y he will purchase, and the total expenditure should be equal to the total income of the consumer, which is being denoted by m. Okay, so his income should get exhausted on the consumption of these goods x and y, given the prices of good x and y. Graphically, what exactly is meant by this and what is its interpretation? So if I draw a simple graph here to make sense here, so let us assume we have the good x on the horizontal axis and good y's on the vertical axis. Okay, now the consumer is being constrained by this budget. Okay, so let's draw the budget line here. Okay, this is the budget line and its intercepts will be, so if the consumer consumes only, let us suppose to draw the budget line, let us put x is equal to 0, that means, rather let's put y first equal to 0, that means x will be equal to m upon px. So the x intercept will be m upon px when the consumer only consumes good x, and the y intercept of this budget line will be when x is equal to 0, so here the y intercept will be m upon py. Okay, we assume this is the budget constraint of the consumer. Now the endeavor of the what we call the endeavor of the consumer is to maximize his utility. Okay, so the consumer is facing this budget line. So with this budget he wants to maximize his utility. That means let us suppose this is the indifference curve first, IC1. Let us say this is indifference curve IC2. Okay, so consumer will maximize his utility when the slope of the budget line is equal to the slope of the indifference curve. And what is the slope of the indifference curve? Okay, so slope of the indifference curve, I will explain it here, and I'm really sorry for this background noise. Okay, so consumer will I will say consumer will choose its optimal bundle when the slope of the indifference curve and the slope of the budget constraint are equal, and it happens at a point where the indifference curve and budget lines are tangent. Okay, corresponding to this we want to find out the demand functions for good x and y. By the way, when we are maximizing the utility with the given budget, we call this the Marshallian demand function. when the demand for a good is a function of income and prices, we say it is the Marshallian demand function when we held the nominal income of the consumer constant. Okay, so I thought it was necessary to interpret it economically here. Now, how do we approach this question? Very simple. What we do, we need to find out the tangency condition here and what we call the first order condition. Okay, so first order condition for maximization requires that we equate the marginal rate of substitution between good x and y, and it should be equal to the slope of the budget line, that is price of x upon price of y. Okay, so MRS is the slope of indifference curve, and px upon py is the slope of budget line. Okay, I hope I am making sense. Now, what is MRS? MRS is simply the ratio of the marginal utilities of good x and y. Okay, and let me write it here if I have the space. Okay, so MRS is simply the ratio of the marginal utility of good x and marginal utility of good y. Okay, and what is marginal utility of good x? Marginal utility of good x is simply the partial derivative of the utility function with respect to good x. Okay, so we take the partial derivative of the utility function with respect to x. Okay, since we are taking partials with respect to x, the exponent of x will become coefficient, so we have alpha will become coefficient, then we have x, and exponent is subtracted by 1 by power function rule. Then we have y raised power beta. It will remain same because we are taking partials with respect to x only. Symmetrically, marginal utility of good y implies the partial derivative of utility function with respect to good y. And this time, since we are taking partials with respect to y, the exponent of y will become coefficient, so we have beta. X to the power alpha will remain same because we are taking partials with respect to y, and the exponent of y will be subtracted by 1. It will become beta minus 1. Okay, now we are done with the MRS. So MRS is equal to marginal utility of good x upon marginal utility of good y, that we calculated. So can I write alpha x to the power alpha minus 1 y to the power beta divided by, so this is mu x divided by mu y is beta x to the power alpha y to the power beta minus 1, and it should be equal to the ratio of the prices, that is price of x upon price of y. In fact, at this point our MRS is equal to the ratio of the price, that is price of x upon price of y. So MRS is simply the slope of this green curve, and px upon py is the slope of this budget line. Having said that, now let's do some basic calculation here. Can I rewrite here? Okay, so I will rewrite it here, then I will rub it, so bear with me. So I have alpha divided by beta as it is. I will transpose y to the power beta minus 1 to numerator. What will happen? We have y to the power beta here. When I transpose this term, the exponent sign will change, times y to the power, if it is plus beta, it will become minus beta. If it is minus 1, it will become plus 1. Okay, simple law of the algebraic law. Transposing numerator to denominator or vice versa changes the exponent sign. And if I divide it by, first I write x to the power alpha, and then I transpose this term x to the power alpha minus 1 to the denominator. So obviously it will get multiplied, but the exponential symbols will change. So if it is, exponent sign will change. If it is plus alpha, it will become minus alpha. If it is minus 1, it will become plus 1. Okay, I am just trying to solve this stuff here. Here bases are same, we can add the exponents. It will become, we have alpha upon beta first, we have then y to the power beta minus beta plus 1, and here we have x exponents. So bases are same, we can add up the exponents. We have alpha minus alpha plus 1. Okay, beta minus beta is equal to 0, so we get y raised power 1 here, so we get alpha upon beta. Here we get y only, because y raised power 1 is equal to 1. Here also alpha alpha gets cancelled, we are left with x raised power 1, which is simply x. Okay, so in this place can I write alpha upon beta y upon x is equal to price of x upon price of y? I can write it. Let us solve this for y. So can I write it like this? Y is equal to, we have alpha upon beta transposing to RHS, it will get reciprocated and multiplied. It becomes beta upon alpha. Okay, then we have price of x upon price of y, transposing this, it gets multiplied. Okay, now we plug the value of y is equal to this stuff into the budget constraint. We plug it here. Okay, so let me rub this first. So we are actually calculating the demand function for good x and y first, then we will solve the second part. So transposing this, so we will get here, sorry, inserting the value of y in the budget constraint, we have price of x into x plus price of y times the value of y is beta upon alpha price of x upon price of y times x should be equal to the income of the consumer. Py gets cancelled, we are left with here px into x and px into x. Let's take it common, px into x. Here we are left with beta upon, rather in the first term we are left with 1, and in the second term we are left with beta divided by alpha should be equal to m. This becomes px into x times alpha plus beta divided by alpha should be equal to m, or it implies x will be equal to, if I transpose it, it will get reciprocated, so it will become, or let me write it here. So we have m divided by alpha plus beta divided by alpha times this px, or x will be equal to alpha times m divided by alpha plus beta. Simple, I reciprocated it, so this came to the denominator. Then we have also price of x here. This is actually our Marshallian demand, what we call the ordinary demand function. Okay, by the same logic we have to calculate the demand function for good y. Now how do we calculate? Simply plug the value of x here. Okay, we will get the demand function for good y, and let me in fact solve. So y will be equal to, y subscript m means that it is the Marshallian demand function. It will be equal to, so we have beta upon alpha times price of x divided by price of y. In place of x we have this stuff, alpha m divided by alpha plus beta times price of x. Now this px and px gets cancelled, also alpha and alpha gets cancelled, so we are left with, and let me write it here, y sub superscript m means we get beta m divided by, here we get alpha plus beta times py. Okay, so this is the demand function for good y. Now let me rub this out to solve the second part. Okay, now the second part tells us, show that these demand functions are homogeneous of degree 0 in prices and income. By homogeneous, what we mean, we are saying, let us say I have a function f of x. y. I am saying this function is homogeneous of degree, let us say of degree n, if I increase both x, or if I scale up both x by a factor lambda and y also by a factor lambda, and if my new equation becomes like this, lambda raised power n times the original function, that is f of xy, I am saying this function is homogeneous of degree n when each input or factor is increased by a constant, and if I get it equal to lambda raised power n times the original function, I am saying this function is homogeneous of degree n. Now we have to prove this function is in fact homogeneous of degree 0 in income and prices. That means, can I write this demand function? So here you can see x is a function of two things, that is the income and the price of good x. Okay, I'm just writing it in the functional form, which is equal to alpha times m divided by alpha plus beta. Remember, here alpha and beta are constants, we have nothing to do with these things. Then we have price of x. Okay, now to prove that it is homogeneous of degree 0 in income and price, let us increase both income and price by a factor lambda. So let us increase, and let me write it here, x star. Let us increase m by a factor lambda, and also price of x by the same factor lambda, that is lambda times price of x. Now what will happen here? So we have alpha as it is, so m is increased by a factor lambda divided by, then we have alpha plus beta, and here also price of x is being increased by a factor lambda. Okay, now what happens here? Can I write it in this fashion? Lambda, if I transpose this lambda to numerator, it will get multiplied and its exponent sign will change. So we have lambda times lambda raised power minus 1 times alpha m divided by alpha plus beta. Okay, so bases are same, we can add the exponent. So this becomes lambda raised power 0 times, what is this function? This is our original demand function, this function. So can I write it? How do I write it? Can I write it in this fashion, that it is equal to x, which is a function of income and price. Okay, now what has happened here? When I increase both income and price by the same factor, the demand has not increased at all, because lambda raised power 0 will be equal to 1. So doubling the income and the price does not increase the demand at all. Okay, so by homogeneous of degree 0 in prices and income, it simply means if I double the income of the consumer and also double the prices of the good he is purchasing, his demand will not change at all. Okay, so this is the meaning of the homogeneous of degree 0. Okay, so that is, let us suppose initially consumer was consuming, let us say he has an income of $40 and he was consuming 8 units of good. Okay, when, or let us let me write it here, the consumer has initially an income, how do I let me see if I have the space left somewhere. Okay, yeah, okay, let us suppose I am saying that, let us say initially the income of the consumer is $40, price of good x is, let us say 10, and he was consuming 40 divided by 10, which is equal to 4 units. Okay, now let us increase, let's double the income of the consumer to 40 to 80 and double the price of good x to 10 to 20. Now what will happen to the demand for the good x? That will be equal to new, this is price of x, oops, so price of X has been increased, doubled, the way income has been doubled, so from 10 to 20. What happens to the new demand? Let us denote it by X star. It will be equal to the new income, price of good X, the new. Here you can see new income is 20, rather new income is 80, and the price is 20. Again he is only consuming 80 divided by 20 will be equal to 4. Okay, when we increase both the income and the price of the consumer by the same amount, the demand of the consumer does not change. That is the meaning of the homogeneous of degree 0 in prices and income. I hope I make myself clear in this video. So I'm just making these videos for free for all people. Okay, I know that some people charge hefty amount of money for these videos, but my endeavor is to make myself as useful as I can, okay, to make value addition to this YouTube community. Okay, so if you really want to support me, please share this channel with your friends. They will benefit from these lessons, and also subscribe. Okay, that's the only motivation for me to keep going on. Okay, see you in next video. Thank you.